Hey there, Chemistry 1. We're going to start our final unit that's going to take us to the end of the semester. It's going to be over the periodic table and the group of the elements on the periodic table. When we're looking at our history of the periodic table, the first thing that we're going to look at will be a couple of laws. Our first law is going to be over the law of triads. This was calculated by a German chemist by the name of Johann Dobeneer. Basically what he did is he looked at a group of elements based on their similarities, in particular their mass. So calcium has the mass of 40, barium has the mass of 137, and strontium has the mass of 88. When you add together the first and the third element in that triad, those three, and you divide by 2, just the basic average, you get the mass of the middle element, which is strontium. So if you go to your periodic table and you look at the mass of lithium, it has the mass of 7. So let's see if I can get my pins to work here. Lithium has the mass of 7, and potassium has the mass of 39. When you add them together, and you divide by 2, you're going to get the mass of 23, which is the mass of sodium. So basically, the law of triads is saying that the middle element in your triad has the atomic weight or mass number or atomic mass that's the average of your first and your third metal in that group of 3. The law of octaves was created by John Newlands. He was an English chemist. And please note the time here. During this time, there are only 62 known elements, and they were placed in the order of increasing atomic weight. And he noticed that after every 8th interval, he would notice a repeating chemical or physical property. So think of 8. There's a musical connection there, such as your musical scale of notes of 8. So basically the law of octaves are stating that elements exhibit similar behavior to the 8th element following it on the periodic table. Mendeley is actually the first one who's given credit for developing the periodic table, and that was in 1869. It was arranged in atomic mass in horizontal rows. If an element did not exist, he left an empty space for it and predicted the properties. Well, there was also another gentleman by the name of Walter Luther, and he was a German chemist, and he was studying the periodic table like Mendeley, but he's not given credit because of the fact that he didn't predict and leave the open spots for the elements. He did, but he didn't predict those elements that were not discovered. So the periodic law, the first periodic law, is the basis of the periodic table, that the chemical and physical properties of elements are a periodic function of their masses. So we've already talked about and listed your alkali metals and your halogens, so they have similar chemical and physical properties, which we'll discuss more in this unit. Moseley is our other gentleman that's associated with our periodic table, and he arranged the periodic table. He took Mendeley's periodic table and arranged it by atomic number instead of atomic mass. And we now have the modern periodic law, in which chemical and physical properties of elements are periodic functions to their atomic number.